All right, hey everybody. Troy Daniels here, technical trainer, SimpliPhi Power. Looks like we got quite a few people in. I'm sure some more people might trickle in. So if you hear me repeat myself, just want to reiterate a few things. But for sake of time, we'll go ahead and get started. So just a few housekeeping items that I always like to mention. First and foremost, if you've got questions during the presentation, there's a spot. If you scroll up to that top control bar that says Q&A, you can type in questions there, and we'll carve a little time out at the end to get through those questions. A few other notes: NAPCEP certifications. If you're looking to get CEU credits for this training, shoot an email to training@SimpliPhiPower. I'll type in at the end that's training@SimpliPhiPower.com. Just say, hey, I attended the training. This is my full name, how I'd like it to look on the certificate, and I'll shoot you over that certification to send an NAPCEP. Really excited to kick off the year here. This is my battery 101. We're going to talk a little bit about the AmpliPHI in more detail, though, our newest battery. Really excited to see what's coming this year. We've got a lot of trainings on the books. Keep an eye on that calendar. We're going to have a lot at once that's going to go up there. And we're really excited for some of them that are really pointed trainings and application-specific trainings. All right. I'm sure I missed a few housekeeping items, but for now, I think we'll stick right there. All right. So I want to get started just talking a little bit about the company history and the overview of SimpliPhi Power and really our messaging and what we bring to the table. So 2010, we were actually founded as OES Energy, and looking at where the drive was, we actually started in the film and broadcast industry, and even at that point, our drive was safe, reliable, clean energy. We wanted to decarbonize while also providing the safest chemistry for a lot of replacements, looking at the issues that were currently in place, things like dying lead acid batteries, even lithium batteries that were not safe and were prone to thermal runaway. So our main goal is, how do we overcome this problem? And that's really the foundation of where we started in 2010. Now in 2011, 2012, we were given a really good opportunity that I'll talk specifically to, which is our work with the Department of Defense and our military projects. At the time, they were seeing huge failure rates of lead acid batteries, extremely high diesel consumption, and they actually had said no lithium batteries. The reason for that, catching fire, what you hear about lithium batteries is the stigma. So we were actually given the opportunity, using our lithium iron phosphate chemistry, LFP, to go in and prove our technology as being resilient and safe. The applications they were used in were high temperature, a lot of movement, really rugged conditions. And the greatest part is we were able to prove that our chemistry and our battery design held up even in these harsh conditions, was safe, was reliable, thus kind of solving the issue that we set out to solve. But we didn't end there. 2013 to 2014, we extended our product line, looked towards more plug and play options, helping the installer, helping the end user, looking at, pre-programmed, pre-wired systems, and again, kind of continuing to solve that issue of what is the easiest, safest, cleanest way to get energy. Something we really were focused on, and we still are, is also distributed assets. Looking at, almost the best and most reliable way to ensure the grid safety is making sure that your assets are distributed. This allows for multiple points of storage to be around, and for a lot of customers to actually own that storage. And actually be, somebody that's storing their own power production that's coming through. 2015, 2016, we actually relaunched the SimpliPhi Power. We continued to grow our business there, more validation, more testing, again, working really hard on those turnkey solutions while also keeping the main focus on clean, reliable, safe battery chemistry, which is our lithium iron phosphate. The big difference to look at here is when we're talking about those other lithium batteries, especially dating back to this military project, they were cobalt-based batteries. These are prone to thermal runaway, and they tended to have issues with going into thermal runaway and catching on fire. They were toxic, and we really were striving to overcome that. And lithium iron phosphate does not have these same properties. It does not have the chance of going into thermal runaway like the cobalt-based lithium batteries do. It's more reliable and safer. So 2017 to 2020, what we've really been doing from there is ramping up production, trying to provide more batteries and kind of refine our product line while really expanding the technology behind it. We've even added some products to fit larger scale projects like C&I. The idea being that any customer, any use case, we're trying to fit into all of those and show that LFP can be used in all of these different types of applications. So regarding, application wise, it's kind of important also to look at, what are some of the big applications that we might think about when it comes to, saving a customer money, which is a big one. Financials are key oftentimes when selling a solar plus storage system. So peak shaving is something that definitely our batteries are great for. We're talking about high peak demands where you go over a certain amount of power and you're charged, X multiplier for that. With a battery, with one of our batteries, we actually have the ability to discharge very fast and have a high surge rate. So we can cover these demands when they happen using certain software built into a lot of inverters nowadays to actually cover those peak shaving demands and cut it out of the bill. So I see this a lot more in commercial applications, but I'm hearing now that they are also coming up in residential applications too. Time of use, my biggest thing to think about when it comes to owning your energy. Customers owning their energy. A lot of customers don't know that they're just basically selling. They don't own their solar. They're just selling it right to the grid. If they want to use it at a certain time, they have no option to do that. By adding a battery in place in these systems, especially retrofits, now the customer is empowered to own their energy, own that power that's being produced, and use it when they need to. Time of use is really when we're looking at it, we're looking at, hey, the utility company is going to charge you at these peak times. So it's, maybe 5 to 6 p.m. when most people are getting home. I know that's not really the case right now, but when we go back to normal life, hopefully that'll be right around there as well. But that's the time that they're going to charge you the most. A battery can help cut those costs and not use all of that solar production throughout the day to own your energy and cut down on that rate. Really looking at integrated solar and storage as a whole, that's the big ticket. Owning what you're producing, being able to use it how you want to use it. And a lot of customers see the value there of why they want to truly take back a lot of that that's being sold off and store it for what they need to. And they can still sell it if they want to. Okay, so again, I kind of talked a little bit about it, but to get in the specific specifications of our batteries, there's all these different types of lithium chemistries. We are lithium iron phosphate. This is the safe lithium chemistry. It's not prone to thermal runaway like these cobalt-based chemistries. And we actually manufacture with a cylindrical form factor. So that's kind of the building block of our batteries and what is really put into place to expand our product line. So some things to consider, warranty-wise, this has actually changed. We used to do it based off of depth of discharge. We really now just do 10 years unlimited cycles, regardless of depth of discharge. I will say that 80% depth of discharge, so discharging down to 20% of the battery's remaining capacity, is going to provide a longer lasting life of the battery beyond its warranty period than 100. However, within that warranty period, you can use it anywhere from 80 to 100. EOL, this is a phrase that commonly comes up in warranties related to lithium batteries, especially. End of life capacity, what's expected at that end of that warranty period's end. We call out 80% as our EOL. So let's say, 10 years, you should have minimal 80% of the battery's original capacity. Look into others, you'll find that that's actually pretty high compared to a lot of lithium battery companies that call out a lot lower and maybe even have shorter warranties. Temperature-wise, operating temperature, -4 degrees Fahrenheit to 140 degrees Fahrenheit. This is referring to if you're in standby, so you're not using the battery, or if you're discharging the battery. Charging temperature is a little bit more important. This is 32 degrees Fahrenheit to 120 degrees Fahrenheit. We'll talk a little bit about our newest battery, the AmpliPHI. It does temperature a bit different, but just know for these ones, our standard Phi batteries, there's no internal thermostat or anything, so it's up to the customer to make sure that it's in an area that's going to sit in these temperature ranges. So with that Phi battery, the standard battery, it does come with, every battery comes with an integrated BMS. That's battery management system, as well as a breaker built in for added protection and installation. What the BMS really is doing is some level of overcurrent, short circuit, and charge and discharge protection. These are kind of last stops in this battery, meaning that you still need to program everything correctly. You need to size correctly based on our guides and program correctly, because the BMS can only do so much to protect the battery. If you've miswired or misprogrammed or missized, you still might, the BMS can only do so much. You still might cause damage. So it's important to note that these are really built in to protect, but at the same time, it doesn't excuse not following the guides and installation manuals. One of the biggest things the battery management system does is cell balancing. We want to make sure that all cells are in balance within the battery. This allows us to also parallel large banks, even though each BMS is internal only. We're talking about passive cell balancing or bleeding off resistance, but keeping the batteries in balance is key when it comes to lithium batteries. Key feature-wise, an important one to think about, C/2. And when we're talking about C rate, we can be talking about a few things. I think a lot of people think of C rate as, hey, this is what the battery is rated at, meaning that when it's given its designation of, let's say, 50 amp hours, 24 volts, it was at a C/20, thinking lead acid. We do rate our batteries at C/2, meaning that 3.8 kilowatt hours is at C/2. That being said, we also look at C/2 as it's the max continuous charge and discharge, meaning, if we've got a 3.8 kilowatt hour battery, we can discharge 1.9 kilowatts per hour for 2 hours out of that battery, or charge that way. The biggest advantage I see is with charging when it comes to residential systems. We can charge from, let's say, a PV source or even a generator or grid, and we can cut down on the charging time, pump more amps into it, while basically, using up the sun while it's out. And that can also, translate over to generators where you need to run your generator less. On the discharge side, it definitely does help. C/2, you're probably not going to come across a bunch of residential systems that require a discharge of C/2, but it may happen in other applications. So, biggest feature I see, scalable and expandable. Our batteries are built in these small, nice little building blocks that are designed to be scaled. Simple parallel wiring configurations on all batteries. No series connection when it comes to our standard Phi batteries. The standard batteries do also not have communication lines. That is only our AmpliPHI, which we'll get into here as we're talking about the new battery later on. And when you scale up, you get both energy and power scaling. Expandability, I'm not even going to touch on that because we're going to just show you what I'm talking about. Scalability on the left, 88 batteries in parallel. That's a lot of batteries in parallel. There's actually no limit when it comes to our standard battery, our standard Phi, how many batteries you can put in parallel. Obviously, you might run into limits as far as wiring and things like that. But I mean, look at this system, 300 kilowatt hours, a huge scaled up system. Again, there's small building blocks. They're easier to maneuver. They're easier to deal with if you're installing batteries. Expansion, this one's huge. So, we have the ability to actually go in and add new batteries to old systems. The warranty will always revert to the oldest battery in the system, just FYI, and I try to stick within, 3-year mark if you can. But, let's say, this system here, 20.8 kilowatt hours, scaled up almost 3 years later, I believe, to 41.6, so doubled in size. This can be really helpful if you're, maybe the house is going to grow, maybe the power demands are going to grow, maybe they're adding members of their family. Whatever it may be, or even just to make sure that you don't have to get stuck in this situation where if you size a little bit too small, customer wants some more battery, you can go ahead and add that on. It's really, really a helpful tool. Our batteries are self-contained and stable. No venting, no off-gassing, no maintenance really. We're not talking about specific gravity checks or watering or anything like that. You'll see with the lead acid. And they also have a very low self-discharge rate, less than 1% per month. I do want to note that it's important to note that that's, if the BMS is on, that would be larger. So just, if you were in storage, you want to make sure those breakers are turned off. Anytime the battery is not in use, it's not connected or anything like that, make sure that breaker is in the off position to keep that low self-discharge. It does really help though when it comes to idle capacity. So just, a battery, maybe let's say in a backup situation that the customer wants to charge up fully and then discharge when there's a power outage. It can sit without needing a lot of topping off and still have a really high state of charge. I've been told eventually we're going to get a new picture on this one, but I still love this picture. Before and after lead acid battery. The reason that we would get a new one is, so you see here, these terminals are actually facing down. We no longer recommend that. We would say we'll talk about orientation later. You can put them on their sides, but we don't recommend these facing downwards like that. That being said though, look at the left, pretty dirty looking lead acid battery bank, a lot of corrosion, a lot of cables running all over the place, temp sensors. It's in a battery box. They look flooded, probably needs a vent fan. We've cut down to about 1/3 of the size with our SimpliPhi batteries, and the one on the right, believe it or not, has more power and energy available than the one on the left. All right. So real quick, let's kind of just go through our standard products here. And at the end, I believe we'll talk about AmpliPHI regarding the products. And then we'll go into a little bit, just kind of as a timeline of this presentation. I think we're going to go into a little bit regarding some tools on our website, Levelized Cost of Energy, some sales tools. Then we'll jump through a little bit of basic design installation. And we'll wrap up with a little bit more information on the company and some installer benefits. Okay, our standard Phi. We've been talking a lot about this already. This is our main seller still to this day, the 3.8 kilowatt hour battery. Again, these are small building blocks that come in 24, 48 volt, internal integrated battery management system built in. These are really easy to work with. They're really easy to scale up to fit into applications that, you're not wasting. I had this conversation the other day of a lot of energy waste that happens when it comes to other batteries. What do I mean by that? Looking at a large building block, let's say like a 14 kilowatt hour building block, in that situation, you might end up with a customer overpaying for energy they don't need because they have to buy two 14 kilowatt hour building blocks just to get to 20 kilowatt hours. Now they've got 10 excess. We can avoid that and cut down on that energy waste with our smaller lightweight building blocks. We do offer some smaller products even, 1.4 kilowatt hour battery. This comes in 24 and 12 volts actually. It's scalable as well, small and lightweight. It's only 33 pounds. It's great for mobile applications. Looking at fitting into tight spaces, it's still compatible with standard charge controllers and inverters that we would use for other batteries, like our 3.8. It still has an integrated battery management system. And I kind of like it. It's got the Anderson connectors or the bare wire connectors you can see here. There's my mouse right here. So this is the Anderson connector. You can get that standard. That can really help cut down on space as well in mobile applications that might be kind of tricky to be tying cables together. So this can definitely add a level of safety when hooking this up. But you could also get it bare wire if you want. The access line, I'm going to be very brief here because we are going to talk, there's about 4 slides towards the end that we talk specifically about the access in greater detail. But just know, this is our plug and play, all-in-one unit, batteries, charger, inverter built into it, DC or AC coupled. It's actually NEMA 3R rated, meaning you can go outside with this unit, mount it up out there. No maintenance and top-of-the-line safety. So we'll talk a little bit more in detail about the options with the access unit coming up here. And last, before we get into our newest battery, our high voltage solution is always an option too. I mentioned parallel connections only. These small building blocks can actually be put in series. These are the only batteries we offer that. You can build up between 200 and 800 volts DC nominal. This is for things like microgrids, large scale backup, maybe a restaurant or a grocery store that needs 480 volt 3-phase on the AC side. This is where that battery is going to come into place. Pairing up with those kind of inverters, you can see here in this drawing, hooked up to a Dynapower here. That would be the inverter. That'd be the kind of inverter you're hooking up to with these. You can scale up in that voltage, and then you can parallel those to build up in energy storage. The battery management system is a stack controller. It's external. It is CAN bus, Modbus, and Ethernet ready, as well as it has its own built-in monitoring platform. If you have any high voltage or projects that the high voltage might fit into for CNI commercial projects, shoot us over an email. We actually have a nice project intake form that can really help. Because each of these projects can be really unique. So it's never a bad idea to touch base with us and we can work through your project with you. Okay, our newest addition, the AmpliPHI battery. So looking at the specs, it's kind of, it might seem like it's very similar. 51.2, 75 amp hours, still a 3.8 kilowatt hour battery. The big difference here is that it has built-in comms. It can communicate with the inverter and the chargers that it's set up to hook up to. Its max discharge is even a little bit higher at 10 minutes. So at 10 minutes on the standard Phi battery, it's 60 amps DC per battery. This one is 100 amps DC per battery for 10 minutes. It does have a current limit of 40 battery modules. And that's just based off, a few things and mostly length. So looking at, 131 feet of interconnecting cables, that needs to be, from battery 1 to last battery, and then you can have another 131 feet to the inverter. Dimensions are virtually the same. Weight's virtually the same as our standard 3.8, meaning it can fit into our existing cabinets that we manufacture. It can also fit into the existing wall brackets and energy storage solutions that we have. So again, closed loop communication with the inverter. This is true closed loop. There's no external cards required or, hey, I have this inverter, plug it in. we are working tirelessly on getting more inverters added to this list. This is a brand new product. So currently it's just set up with the Sol-Ark inverter. That is the first one we went with, but we've got a lot more on the horizon that are fast approaching final approval, and we'll have them out. But right now, you're pairing with the Sol-Ark inverter. And what does it do when you pair with the Sol-Ark? It adds this level of auto-populated set points, high-level protection, which we'll talk about in the next slide, smaller battery banks to inverter capabilities. And what I mean by that is right here, flexible sizing. You know, with our standard, we'll talk about sizing a little bit, but with our standard battery, we do have sizing guidelines which need to be followed. It's a 2-to-1 ratio, meaning, you know, your inverter is 8 kilowatt hours. You need 16 kilowatt hours of battery. Not the case with this. If it's hooked up to the Sol-Ark, you could technically have one of these batteries hooked up to a 12 kilowatt Sol-Ark inverter. It does high-level accurate readings for state of charge, voltage, charge and discharge. Now, talking about the protection specifications, you know, we're looking at over voltage protection, over charge and discharge protection, again, tied into that flexible sizing, temperatures, low and high. So this is kind of the part I was talking about. The battery actually has an internal thermostat. It reads temperature. It can ramp down charge rate based on temperature to avoid any sort of overcharging during low temperatures or high temperatures. It also it will disconnect itself if it goes to too low of a temperature, which is a really good feature if you are in a cold area, just to ensure that you do not hit that low temperature. Automatic charging set points. So again, we're putting all the settings into the Sol-Ark itself. I actually have a slide right after this one. We're going to talk a little bit more detail about that exactly. And the BMS is there really to protect in this case. So it does auto-populate set points. It puts in things like absorb, float voltage, EQ voltage, which really is disabled, but it still puts it in. It automatically calculates the battery's capacity and state of charge. So let's say you've got 5 batteries in the system. It knows that just by plugging in and clicking that BMS lithium battery type, it'll say, hey, I know there's 5 batteries in the system. And it'll calculate the total amp hour capacity. And if you add another battery, it automatically recalculates. It knows how much it can discharge and charge. And it knows how to deal with temperature compensation, which really with lithium batteries, we don't temp comp. So that's where it comes into play really nicely to make sure that no settings are wrong. Non-auto-populated settings, the low battery cutout is automatically set for 100% depth of discharge. So you do need to adjust that if you want to 20% depth of discharge, as well as it will not auto-populate settings that might be related to the generator or the grid to tell that to charge. All right, so what are some options with the AmpliPHI battery? Sol-Ark 12K access unit. So we're going to talk again about the access in a little bit more detail, but do know that the all-in-one units you can get with the new AmpliPHI battery. That's a great solution when it comes to all-in-one and outdoor rated. You can also just pair the AmpliPHI battery with the Sol-Ark inverter. You know, just we're talking indoor rated stuff, maybe, you know, making sure you're customizing, picking how many AmpliPHIs you want, picking how many Sol-Arks you want, not an all-in-one solution. And one of our very quickly growing popular solutions, we offer the Boss cabinet in 6 and 12. This is the 6 unit Boss cabinet. You can see it right here as well. You can get AmpliPHI in this cabinet as well. And then you could have an outdoor rated Sol-Ark. So your entire system is still outdoor rated, but you've got the flexibility to size how you want. All right. So we're about halfway through here on the slides. We're going to take a little turn here. We're going to talk a little bit about levelized cost of energy and the cost of ownership of the batteries. How to use that as a tool, how to look at that. You know, what is levelized cost of energy? Really, we're looking at what is the cost of every kilowatt hour I can get out of this system? Looking beyond things like just upfront cost and digging into more things like usable capacity, warranty, efficiency. This is the equation that we would use for that. Very basic equation, price over capacity times the cycles warranted times efficiency and the depth of discharge being used. You can always add an ancillary cost, things like, is there a cost associated with getting a forklift on site for the larger batteries, or some sort of transportation cost that might only be associated with one battery. Don't worry about memorizing this, because we actually have a great tool. Let me see if this will work for me. All right, let me just pop this screen. Cool. So we do have a tool on our website that uses this calculation. That's a benefit to the installer, to the distributor, to whoever might be looking at, even just a customer looking to compare batteries. It allows you to pick your battery type of ours, type in the cost that you'd be paying for it, and you'll be able to get that levelized cost of energy. So I won't go through it here. I mean, if we want to really quickly do it, 3,000, let's say we're using 80% depth of discharge. I can see it's 9 cents is the cost of ownership per kilowatt hour. And then you can compare it to either a lead acid battery or to another lithium. And if you do that, it'll just bring up another screen where it'll keep that calculation, and you can type in the values for the battery you're trying to compare it to and compare the two at a levelized cost of energy. Super helpful tool, really can help bring a customer around that maybe just is looking at upfront cost, and you're trying to sell them on reliability, duration of the battery's lifespan, efficiency, and usable energy. Okay, so that's kind of my sales pitch. I know it's short and sweet, but I think everything I've talked about today is also reasons, looking at what the benefits of our batteries are to sell. But if you're really trying just to dig into those numbers, use that levelized cost of energy. It's a really good tool, and it's available on our website. It's free. It's easy to use. Battery sizing. This is where I would start. We're talking about the design and the installation process. Everything starts with battery sizing. We talked about depth of discharge. Now, while maybe it is not effective of the 10-year warranty, it does affect the expected cycle lives. I would expect that 80% depth of discharge, you're going to last a lot longer than 100% depth of discharge, well beyond that warranty period. So, it all kind of comes down to how are you using the battery? I like to think of mode of operation. If you are in a battery backup situation, you've got a customer that just wants it for grid outage situations, you might be able to size it more for 90 or 100% depth of discharge. They're probably not using as much of that, those cycles, because they are only discharging, let's say, a handful of times every month. So in that case, you could use a little bit more of the battery's total capacity. Off-grid being the other side of that coin. If you are off-grid, you really want to stick with 80% depth of discharge. You want to prolong that life of the battery, and you are using that battery probably daily. You're cycling it daily. So it makes a lot more sense to expand the cycles well beyond that warranty period, and expect that the battery is going to be cycled a lot more often. And my most important rule, again, this does not apply to the AmpliPHI battery when you're hooking up the AmpliPHI to, let's say, the Sol-Ark or soon to be more inverters on that list. However, with our standard Phi products, it's important to follow this guideline. And it's in our warranty, it's in our installation manual and our integration guides. You can't miss it. The battery should be sized to twice the inverter's output capability. That is the minimum, not the maximum. Maximum, there is no maximum. But if you've got, in this example, an 8 kilowatt inverter, the 8000, the Radian 8000, we need a minimum of 16 kilowatt hours of battery. That prevents over discharge, which most inverters do not have the ability to, you can't mess with it. You can't say, hey, only discharge 4,000 watts. So if you just size this correctly, you'll never run into that issue. I see a lot of the time where maybe an installer says, well, I sized it a little bit smaller than it should have been because I knew the customer wasn't going to use that much power. They come back 2 years later, even like 3 months later, and the customer says, hey, I added a hot tub, by the way, I didn't tell you. I mean, they don't have to tell you, it's their power. Now they've added a huge load on and they've over discharged the battery. If you size like this, the customer has no chance of over discharging the battery. It's just the safe way to go. If you're looking for more information on sizing, we've got a ton of tools. I won't click on all of them, but we have a battery bank sizing estimator. This one just takes a basic kilowatt hour per day number and gives you a battery bank that would fit. How many of our batteries and which battery you are looking at would fit that need. The system-based calculator, and I encourage you to watch, I have a training on our YouTube channel called Our Tools, Empowering the Installer, I believe. And that actually shows all these tools in great detail, what the benefits are. But the system-based calculator is a great tool. I'm going to pop into it really fast, but just to show you kind of, I won't go through it all, but I just want to kind of give you a rundown of why it's such an intense, I don't know what the word I'm looking for is, but extensive tool, I guess, and really dives kind of more granular into the system information. So it does take a second to load. Don't panic when you get to the page. There it goes. But it takes into factors like, is the system AC coupled? Is it DC coupled? And it helps you a little bit more with understanding, what's the size of the inverter, what's the minimum battery quantity, what's the size of the charge controller, things like that. So it definitely dives in there a lot more and really can be a good way to double check your work more than anything. We also have the lead acid battery bank replacement calculator, one of my favorites. This calculator, again, I'll pop in really quick. It allows you to type in your old lead acid battery bank and spit out numbers, giving you the exact quantity of batteries you need to replace that battery bank. Also, it contains the lead acid replacement guide on this page. This is a really good tool as well. It talks a lot about resizing, the benefits actually of going with lead acid or a lithium battery over lead acid when you replace. It also talks a lot about reprogramming and, again, understanding how to size correctly. So all of these tools can be found on our website. Actually, let me pop over there one more time here. So if you are looking from the start of the website, so say you're at our home page here, go to support. And under sizing calculations, you can see all these tools right here, and you can just click them, go to those tools. So use them, please. They're up there. They're free. They're really helpful for everything from sales to sizing to replacing. Okay, so we're going to do a little bit of installation here. We're going to talk very briefly. So I want to kind of emphasize that if you're looking for really in-depth installation, I've got tons of other trainings. The big ones I always try to recommend are this one, AC versus DC coupling, and charge and discharge and battery characteristics. Those are the three trainings that are actually part of our IQ program, which we'll talk about later, but they are so important, I think, when it comes to understanding how our batteries should be programmed, wired, connected, used in certain applications, and can kind of give you a full breadth of installation. For this one, we're keeping it really basic, but we're going over the basics still. Okay, I'm going to pop to the website one more time. I lied. So I just want to show you, under our website, you can find tons of resources under product documentation. That's under support, product documentation, spec sheet, warranties, installation, and most importantly, I think, integration guides. These are basically, if you're integrating with, let's say, a Midnight Solar charge controller or a Schneider electric inverter, you can click on this and it'll give you the specific integration guide. It'll call out specific settings that they ask for and what we would recommend that setting to be. So it can really take the guess and check work out of integrating with a specific product. We also have how-to videos. I would definitely check these out as well. Some really good resources here. Some stuff like Sol-Ark access, wiring, even wiring up things like the Boss cabinet, and connecting lugs and things like that. So check all those out. They're really helpful tools as well. All right. Sorry, just looking at questions, making sure I didn't miss anything. All right. Installation, shipping and receiving. If you get the batteries, check the batteries for damage right away. Never a bad idea. Check the breakers. Make sure they're working correctly. You know, once it leaves our facility, it's kind of out of our hands as far as shipping goes, especially if it's coming from a distributor. And never a bad idea to make sure you have the right battery. Check the placard, but you could also take a multimeter test. Installation, as far as, sorry, this is actually mislabeled here, but as far as mounting and clearance requirements, we don't have a lot of clearance requirements, meaning these batteries can sit basically flush up against each other. And that can, you know, not leaving space in there can actually help when you're in tight spaces where you need to fit the batteries in. We can also use our SimpliPhi brackets, like shown here, to mount on the wall. Not a requirement, though. We can do other things like battery boxes, battery racks, orientate, you know, as far as how they're oriented. I actually mentioned this already. You know, here they're upright, but they can sit on their sides. And really the only thing we don't recommend is that the terminals are facing downwards, as I mentioned in that other slide. Wiring the batteries up, you might be a little bit different than you might be used to. So, you know, we're looking at, let's say, a lead acid battery. We typically would, you'd look at positive to positive, post to post, up to a connection point, jumper cables, basically. With our batteries, we want same size, same length cables, all running to a common connection individually. This keeps the efficiency high and keeps the balancing where we want it. So when current's coming in or out, everything's nice and balanced and nothing gets off balance. If you can also do post to post as far as terminal bus bars, like we use in our access solution. But if you are going with cabling and you've got a larger system, you can use things like battery combiner boxes, a lot of power panels that already are built in with the inverter. So, you know, if you're buying a Schneider with the power panel, you probably have a bus bar built in. You might be able to use for a few connections. But really, we're just talking about basic DC busing here. So great example, you know, looking here, a lot of batteries running to a common bus connection point in this combiner box. Probably don't need these surge protectors and the extra breaker, but it's, you know, a little extra protection never hurts. And then they're running from there to the inverters in this load center here. Okay. Torque specifications. This one is a good one to pay attention to. You know, 160 inch pounds. Over torquing the battery will damage the terminals. So do not over torque. You might feel a little give getting up to 160. That's normal. The little rubber stopper that is meant to do that. But do not use anything but a proper torque wrench. I see too many times people use an impact wrench and just try to use, you know, their feel, and they snap the terminals. If you're using a proper torque wrench, you're not gonna be able to snap the terminal because you really would have to put, you know, triple that, I think, to actually snap the terminal. Also recalibrate. I see that a lot too of systems that, you know, an installer's going from system to system, never recalibrating their torque wrench that needs to be recalibrated, and they don't get the proper torque. Okay, so I mentioned our integration guides. This is actually a little bit out of an integration guide. This one's a little older. It's updated now on the website. But again, these are just pulling out the exact specifications of set points that a charger or an inverter manufacturer is asking for. And we're just telling you exactly what to type in. So it gives you things like, you know, when to use 2-stage versus 3-stage, the settings like absorb, bulk, float, low battery cutout, high battery cutout, max charge rate. It even sometimes gives you things like advanced cell features, AGS triggers, automatic generator starts. So use these, are, you know, they're at your disposal. I think the biggest things to consider when programming a system is the low end and the high end. Take my charge, discharge, and battery characteristics training to learn more about the state of charge versus voltage correlation. But 48.0 on a 48 volt battery is 0% state of charge. So if your low battery cutout is below that, you can you're discharging way too far and you need to up that. On the high end, I typically don't go 56.4, I think is the highest I typically recommend, and that's only on one charge controller specifically, but 56.0 at 6-minute absorb time, that's the best absorb that I currently use. And this is actually, again, outdated. You'll see our newest specs, a little bit more updated on the website. Always, to that point, the reason I keep this up there, the point being always pull documentation off the website. Refresh your browser, pull it off the website. Don't keep old manuals. Pull the most recent documents off. It'll give you the best information. Okay, a little bit about the access solution. Again, pre-wired batteries are in there, charger, inverter, pre-programmed wiring, can be AC, DC coupled. The two different types of access are the Schneider access, where we're using Schneider components. So you'll see here the XW Pro, the 600 volt charge controller. If you want to go DC coupled, it does come AC coupled standard, meaning if you buy this without the charge controller here, it'll just be the XW Pro inverter with the batteries, meaning that would be for retrofits and AC coupled systems. As far as monitoring goes in this system, we're just using the COM box, which is actually now, I believe, the gateway. And that is just the monitoring platform where we can use Insight and actually see, historical monitoring, which can be a really good tool for any sort of troubleshooting or seeing your production and understanding, what you can do with your stored energy, as well as we can see real-time data here as well. Customers definitely like seeing this on their phones, tablets, laptops, whatever. The other version of the access solution is our Sol-Ark access. This is with the 12 kW Sol-Ark. Has the MPPT built in, meaning it can be AC or DC coupled, no matter what you do. So if you buy this unit, it has both options built into it. Can do some pretty cool functions when AC coupled, like self-consumption and time of use. And actually even has the ability to add a button for rapid shutdown. So, it's got those triggers built in for that battery level shutdown using the inverter, which can be helpful in certain NEC requirements. This one actually has the option of being paired with the AmpliPHI batteries. So we can set up with the advanced comms with the Sol-Ark inverter, and we'll be able to get, it does auto-populate, which is not really a big deal with the access because we do that as well with the other ones, but you get these really high-level SOC readings and accuracy. But again, you can get the Sol-Ark access with the AmpliPHI batteries currently. As far as monitoring goes, we're talking about basically the same kind of platform as the Schneider. Historical monitoring, real-time monitoring, wireless programming, which is not available on the Schneider. But again, looking at your tablet, your cell phone, customers can see these monitoring platforms, and they always love to look at it. So definitely can be a big selling point. So again, AC or DC coupled. Something also to consider with the access solution is the automatic transfer switch to disconnect from the grid is built in. That is built into the inverter charger. And that is part of, so you don't necessarily need an ATS. If you have a sub panel in, you don't need an automatic transfer switch. It's already built into it. If you're going AC coupled, there's definitely a little bit more guidelines regarding sizing of PV and things like that. Again, check out my AC versus DC coupling training, but also, through the manuals, you'll find a lot of that info that gives those specific numbers. Oh, one more thing, you can, at least on the DC coupled side of things, we can add generators as well to these access solutions. Okay, I just want to wrap up talking a little bit about our IQ Elite Installer Qualification Program. This is something that we are really passionate about, getting more installers qualified for this program. You probably already are qualified if you install our batteries. So we're just trying to get people to send in their applications. what is this program? Why become qualified? Well, as an installer, you end up on our where to buy page. So you have visibility here. If somebody's surfing the web, looking at our page, looking at, hey, who's in my area to install batteries? I want to buy these SimpliPhi batteries. You'll pop up as that little blip with your information for your company and contact information. Really can drive a lot of business towards you. Again, if you're installing our batteries already, just the application is super simple. I showed it at the very end. I would get it done. We also are going to start highlighting project deployment and company throughout our SimpliPhi marketing. So, these are high-level marketing that we're doing, as well as adding in our elite IQ qualified installers. And we have the newsletter is actually coming out here. Might have already actually came out, so I'll bite my tongue if it didn't, but it is coming out very soon, if not, which will be a recurring newsletter showing various highlights of who's doing what and highlighting different projects and things like that these IQ elite installers are doing. Distributors also want to sign up. If any distributors on here right now, this can increase the sales from these installers that are already buying from you anyway. They can highlight your installer customer projects, which is never a bad thing. Show off what they're doing already. And it always increases the knowledge base and more successful installations with the SimpliPhi products. So I kind of wrote this and I like to just read it direct. Show distinction over other installers with the IQ logo and branding. Join our Elite IQ program and become part of our ever-growing network of trusted and knowledgeable installers. Again, if you are already doing this, if you're already installing batteries, I'll show you the qualifications and it'll make more sense. But, maybe if it'll let me, let's see. No, it's not going to let me. So if you go to our page, you'll end up on our application page. If you scroll down, you'll see the application. It takes about 10 minutes. Requirements are attend this training here that you just attended. You have to watch AC and DC coupling or attend on our YouTube channel. You must have installed 2 SimpliPhi installs, and then you're IQ certified. You can use our branding. We offer swag that we send out. And again, all these benefits of ending up on the map and the joint marketing efforts. As well as we'll actually be inviting a lot of these IQ program installers to talk on webinars if they are, of course, comfortable with it, and show off their installs and really kind of show what they've been working on in the field. Application takes 10 minutes. If you can't find it for any reason, shoot me an email at training@simpliphipower.com. I'm happy to direct you in the right direction. So just to kind of bring it all kind of together here, looking at what we're doing as a company, we're accelerating the energy transition, decarbonization. We're looking at, how can we cut down on the effects of climate change, CO2 emissions, as well as really driving that switch to renewable energy, whether it's, through wind, solar, but everything tying back to energy storage being a big key element here. Reimagining the power grid. The grid is unstable. We're seeing that already. Think of these blackouts, these planned blackouts. We're reimagining how this power grid is put together. Again, distributed assets. I am a strong proponent of distributed assets. Looking at, having a battery in that home makes a lot of sense. Taking the load off the grid while also keeping your lights on. Building a more resilient future, something that's going to hold up, long-lasting, resilient batteries. This is why our chemistry is so important. And cash is king, delivering economic value. I think I just read that solar energy is currently the cheapest form of energy in the history of humankind. That needs to be stored. We're there to help deliver that by bringing our battery costs down as much as we possibly can over time, while also keeping reliable and safe chemistry to truly help mitigate those economic, or to add to the economic value and store your energy, while also looking at distributed assets and how we can cut down or add to economic value and cut down on charges like peak shaving and time of use. All right, with that, I will start looking through some questions here. I'm actually going to go ahead and pop out real quick. I'm going to type in, if it'll let me. All right, well, we'll do it right here. I'm going to type in the email address. So if you have any questions about our IQ program, or more importantly, also, if you are looking for NAPCEP certified credits, I know everybody always is. Like I said, just shoot over an email at training@simplifypower.com, and I will be able to write you up a certificate that you can send off. Okay, a lot of questions. If you have any questions that you didn't type in, go ahead and type them in right now. We'll try to get through all of these. I know we're right at the top of the hour, but not a problem. What is the difference between lithium iron phosphate and lithium cobalt? Again, it's really looking at, the chemistry used. Lithium ion as a whole is not every chemistry. Lithium iron phosphate is more reliable, does not have a chance of thermal runaway like the cobalt-based batteries do. Please speak to installing in dry but not climate-controlled spaces like outbuildings, and temperature and humidity effects variations on the batteries. So again, I mean, obviously every battery loves 25C. It's the magic number. Our batteries can operate within the range that I mentioned, looking even down to 30 degrees. However, obviously the less the kind of perfect 25 you can get to, they're going to operate the best. Humidity, we've got some really humid places where our batteries installed. I've seen a lot of batteries in Puerto Rico. Firsthand myself, they don't seem to have issue. My general rule of thumb is if it's so humid it's causing water buildup, then it's too humid probably in whatever space you're using. Dry, I don't see too much effects there as well. All right, for the 3.8 battery, can use two 3.8s with a 4 kilowatt Schneider Connex inverter. Technically undersized, so you are running the risk at that point of possibly over discharging the battery. That being said, I do see, slightly undersized systems sometimes do operate okay if you know the loads really well. But again, the risk is always there. Regardless of the warranty period, is the 10-year warranty, regardless of depth of discharge, retroactive to batteries sold when the warranty was 10 years only with 80%, such as those purchased in 2019. I'm actually not 100% on that. So if you want to shoot me an email, if you're asking for NAPCEP especially, just remind me. I will ask somebody higher than myself on that one. Whoops. Did you say that if a battery is added 3 years later, the warranty that applies is the oldest battery, meaning is the new battery only warranty for 7 more years if you added it to a 3-year-old system? Yes, correct. So it is always the least common denominator. So whatever battery is the oldest, they all revert to that warranty when adding new batteries. So you don't want to do it too late. What is the best way to tell a PV off-grid customer what to look for regarding, basically asking, state of charge on the lithium iron phosphate battery, voltage, or, looking at a battery monitoring kit, amp hours in, amp hours out. Well, older stuff tends to be pretty rough when it comes to lithium batteries. I saw a trimetric the other day that definitely was not going to be able to work. Just wasn't designed with that in mind. I always recommend the Victron BMV 712. It's the most accurate monitor I've found for lithium iron phosphate batteries. Our AmpliPHI battery reports its own state of charge. And other than that, some of these battery monitoring kits can be manipulated to work even if they were not designed with lithium in mind. But check out my training that's all about characteristics of our batteries. We talk a lot about that correlation. There's like 10 slides that just go over exactly how to understand that correlation. will the SimpliPhi battery work with the first generation low DC voltage store-edge inverter? I didn't even know they had a low voltage store-edge inverter. So send us the specs. I'll have to look at that. I've never been aware of that. So we're happy to look into it for you, though. Can I use a couple of these slides on my website, specifically the equation with link for levelized cost of energy? Sure can. Let me double check with marketing. But yes, they probably would ask, maybe even just link it. But shoot me an email. It's training at SimpliPhi Power, and I'll pass it off to marketing, make sure that's okay. But I don't see why not. The architecture, I'm not sure if this is referenced to something else, but talking about exposed cables, no conduit, what are the code ramifications for installations? Yeah, I'm not going to get into it because all code's so different judging off of area. We actually have some trainings coming up where we're going to talk to specific installers, probably IQ installers, by the way, in certain areas, and let them discuss a little bit about their code requirements that they see in their specific areas. But I try to stay out of it a little bit, as every single inspector is going to have a different interpretation of code and maybe even different rules. So again, talking about state of charge, do we sell a device for this? Again, I would look at the Victron BMV 712 battery monitor. Jason, good to hear from you. Haven't talked to you in a while. One of our lead installers, but not just for lead installers today. But give me a call sometime, Jason. Long time no talk. What are some of the common installation mistakes you've seen installers make in terms of installation instructions and or NEC code requirements? On our end, installation mistakes, I see a lot of missizing, a lot of, believe it or not, non-programming. So just putting the battery in place, not programming it. That's a lot of it is on the do-it-yourself people as well. As far as NEC code, I won't touch it again. Sorry, it's just too complicated when it comes into, different jurisdictions. What are the recommended training videos and webinars for proper installation for new technicians? So yeah, pop onto our YouTube channel. There's a whole section called IQ trainings, and you can actually go through all of those if you want, but the majority of them is this one, AC versus DC coupling, and also looking at charge and discharge and state of charge battery characteristics. Those are the three I always recommend. They're actually the three that are required for our IQ Elite program, as well as on those videos I went over on our documents page, where it's talking about looking at exactly how to connect the batteries, things like that. Those are always good as well. Sorry, question in Spanish here. I'm sorry, I don't speak Spanish, or I'd put it into a translator, but I can't pop out of this. If you do have a question, we do have Spanish speakers on our team. So if you have a question that you want answered in Spanish, feel free to either call us or just shoot an email and we'll get you over to them. Question about becoming a distribution partner. Shoot either me an email if you're interested, or sales@simpliphipower.com, and they can qualify you to see if you fit into our distribution program. For grid scale applications, asking if we have a solution there. Really, we don't. Commercial industrial is about as large as we go with our high voltage product, but we really, if we're talking utility scale, like 200 megawatt hours or something like that, or even probably like 20 megawatt hours, we typically don't go that big. Jason's corrected me. Thank you, Jason. So the Schneider actually can be programmed now by tablet wirelessly. So I think that's what he's referring to is only with the gateway, I believe. So that would be with our access then. Okay. So Nancy's asking for warranty registration online. Where is the serial number located? There's a little placard on the top of the battery with the serial number. Is the SimpliPhi UL 9540 system certified with the Schneider XW or XW Pro. So the system level, and they're going to beat me up for not remembering whichever one that is, 9540, the system level is currently with the Sol-Ark. And then also you can do it with Skybox and our batteries as well. Do you have a favorite DC combiner box? Midnight combiner box is my favorite. They actually make one specific for lithium now that can be really helpful for landing a lot of batteries. What is the thermal runaway temps for cobalt and lithium iron phosphate? I don't know the specific temperature of the cobalt runaway. If I use Sol-Ark, other in the future that can communicate with the BMS, I can downsize the battery capacity. So yes, you can do that. It automatically will tell the inverter that it does not want to over discharge with that Sol-Ark. So you can size smaller, flexible sizing. Was wondering when we hope to see 230 volt inverter battery configuration. As far as our all-in-one units, we really don't typically do that. I think we've maybe put out a few special cases, but if you want it fast and easy, I would just recommend looking at our Boss cabinet if you want still a cabineted solution with whatever 230 volt inverter you are looking for. Because our batteries don't mind whichever they're working with, but we just don't offer it as an ESS solution. Do you recommend your battery negative terminals taken to earth ground? No, you don't need to ground the batteries, just connect to the negative. Older integration guides, 54.4 was target for 80% state of charge. I'm not sure what that means. The batteries are 1 year old. Should I go there and change to 56 volts? So 54.4 at 1 hour absorb time was the old set point. And 56.0 at 6 minutes is the most up-to-date one. I would change it if you want a little bit more charge. It's not necessarily going to affect the lifespan of the battery too much here. It really is the same thing, but we do see a little bit of a higher charge rate when it comes to 56 volts at 6 minutes. So if you want to change it and it's easy, I would definitely do it. Is there a device to monitor typical energy use in a system that you would recommend for sizing? Enterwise Monitor by Schneider. I'm not really sure. I think that's probably talking about battery monitor, I'm guessing again. Again, I would say the Victron is my go-to. So Victron, you've had like 4 plugs. So I'll be expecting my battery monitor to arrive soon. Is Outback AGS load start function an acceptable means to prevent over discharge of the batteries? Tough question. I would say it's a great way to prevent it if you do undersize the battery bank so that the generator comes on if the load hits a certain X amount of kilowatts. That being said, you're still relying on that programming. So if it fails, you might over discharge still. And if let's say your generator runs out of fuel, you could still over discharge. So it's definitely not the safest bet. Awesome. And last comment, just Jason looking at the his Boss cabinets. Hopefully, Jason, by the way, if you jumped off already, hopefully not. I'd love to see some pictures. I don't think I've received those yet of your most recent Boss cabinet install. So again, Jason is one of our IQ and elite installers. He's been on our website a ton. If you're installing our batteries already, get through that program, become qualified, because we really want to highlight these installers that are doing good work with our batteries already. It's not a requirement to install our batteries, more of an added benefit to the installers already doing it. All right, that's all the questions we had today. Again, if you're looking for NAPCEP certifications, CEUs, shoot me an email at training@simpliphipower.com. Make sure that your full name is included, how you want it to show up on the certificate in that email, either in the the header, in your email address, whatever it may be. Just make sure it's in there somewhere. If you have any questions at all about the IQ program, please shoot me over an email at that same email address. We'll help guide you to the right pages or answer any questions that you may have. All right, thanks everyone so much, and I hope you have a wonderful day.